Product rule. For example, the equation will be 3 to the power 4 and 3 to the power 7. You keep the base, which in this case is a 3, and you add the exponents 3 and 4 together to make a new exponent. So the answer to 3 to the power 4 and 3 to the power 7 will be 3 to the power of 11. Remember, this rule only applies to when both bases are the same. It won't work if the bases are different. And the algebraic rule will be x to the power of z times x to the power of n equals x to the power of z plus n. But remember, if the exponent is an even number, then the answer will be a positive. And if the exponent is an odd number, the answer will be a negative.
Solve exponents with using the quotient rule. But first, you must understand how repeated multiplication works, because one of the strategies involves repeated multiplication. So first, repeated multiplication is the base telling us how many times to multiply the base by the exponent. So for example, 2 to the power of 6. The 2 is the base and the 6 is the exponent. So in this example, you must multiply 2 6 times because it's 2 to the power of 6. So if you write it in the repeated multiplication form, it would be 2 times 2 times 2 times 2 times 2 times 2. Now one of these quotient rules you can use that involves repeated multiplication is basically dividing the repeated multiplication and canceling them. So for example, 2 to the power of 3 divided by 2 to the power of 2. By writing out the repeated multiplication, you can cancel out the pairs. So the both 2's you see are the base, and the 3 and 2 are the exponents. By writing out the repeated multiplication, it can help you cancel the pairs. So for the top, it would be 2 to the power of 3. So writing it out in repeated multiplication, it would be 2 times 2 times 2. And for the bottom, which is divided by 2 to the power of 2, it would be 2 times 2. So when you cancel them out, it will leave one single number that will be by itself that doesn't have a pair. Another easy way to solve exponents using the quotient rule is just subtracting the two powers of the exponent together and the base number stays the same. So for example, 2 to the power of 4 divided by 2 to the power of 5. So you simply just subtract the two exponents together. So it would be 4 minus 5, which would equal 1. So the answer would be 2 to the power of 1. Lastly, the algebraic rule is x to the power of n divided by x to the power of z equals x to the power of n minus z. So for the zero exponent rule, the powers or exponents cancel on each other, which will leave the base by itself because the powers will equal 0. But the fraction is basically one whole because the two bases are the same by itself. So therefore, it would equal one whole. For example, 2 to the power of 3 divided by 2 to the power of 3. So if you subtract the two exponents together, it'd be 3 minus 3, and the answer would be 0. So that will leave the two bases by itself. So if you put the two bases as a fraction, it'd be 2 over 2. So 2 over 2 is also one whole. So for negative exponents, the odd powers of negative bases are negative, and even powers of negative bases are positive. So for example, negative 4 to the power of 3. That will equal a negative base because the 3 is an odd number. So for a positive example, negative 4 to the power of 4. So the answer would be positive because the powers are in an even number. So for the power rule, you just multiply the two exponents together. So for example, the equation will be 2 to the power 3, 2 to the power 3. So the base will stay the same, and you just have to deal with the exponents. So you multiply the exponent on the outside of the bracket with the exponent on the inside of the bracket, and that will be a new exponent. So the answer for 2 to the power 3 to the power 3 will be 2 to the power 6. So you're basically just multiplying the two exponents together to make a new one. The algebraic rule is x to the power of z to the power of n, and that will equal z times n. This rule will work for both negative and positive exponents.